Hi, Mr. Richards here, and today we're going to learn about solving systems of equations by graphing. And this is really an exciting lesson. A campground offers tubing, kayak, and bicycle rentals as shown. You can rent a tube with a $15 deposit at $4.20 an hour, a kayak for a $25 deposit at $6.50 per hour, and a bicycle with a $20 deposit at a cost of $7.50 per hour. And our first question asks us to write an equation to represent the total cost y of renting a tube for any number of hours x. Well, our total cost is going to be y, and that is going to equal, well, for the tube, we have a $15 deposit. Now, no matter what, we have to pay the $15 no matter how many hours we rent. So that's just going to be 15. And then we have to add that, let's see, for our hours it's going to be $4.20 per hour. So we can write that $4.20 per hour, which our hours are going to be x. So we have our deposit of $15 plus $4.20 per hour x. Now we can do the same thing for the kayak. We can say, all right, y equals, our deposit for the kayak was $25 plus $6.50 per hour, which is an h. Tempting to do h. It's actually, in this question, x. And then for the bicycle, we're going to have y equals the $20 deposit plus the $7.50 per hour x. Now to find the cost to rent for 1, 2, 3, 4, and 5 hours for each, we can use the equation. We can say, all right, for our tube, it's going to be $15 plus $4.20 times 1. And $4.20 times 1 is $4.20 plus the $15 is $19.20. We can continue down our table. We're going to have our $15 deposit plus $4.20 times 2, and $4.20 times 2 is $8.40, plus the $15 is $23.40. Continuing, we have 15 plus $4.20 times 3, and $4.20 times 3 is $12.60, plus the $15 is $27.60. Then we have 15 plus $4.20 times 4, and $4.20 times 4 is $16.80, plus the $15 is $31.80. Then lastly, we have $15 plus the $4.20 times 5. $4.20 times 5 is $21, plus the 15 is $36 even. Now we can do that for every single part here, except we're going to use the different equations. For the kayak, we'll have the 25 plus $6.50 times and you can go ahead and fill in the table here. And as we have that kayak row now filled in, you can see the 25 plus $6.50 times 1 was $31.50. $6.50 times 2 plus 25 was $38, times 3 and adding $44.50, $51, and $57.50. And we'll use the 20 plus $7.50 times 1 and so on to calculate the cost of the bicycle. And there we have that part of the table completed, with the 20 plus $7.50 times 1 being $27.50, $35, $42.50, $50, and $57.50. And you can pause the video if you need to complete your table. But looking at this, I see something very interesting here. I see the cost of 5 hours for the kayak and the bicycle being the same, even though there were different deposits and different hourly costs. Interesting that there's a little bit of an intersection there. Now, today's activity involves solving systems of equations by graphing. What we're going to do today are to take equations like this and look for points of intersection if they exist. And one right here does for our cost of the kayak and the bicycle. Now, what is a system of equation? Two or more equations with the same set of variables are called systems of equations. For example, y equals 4x and y equals 4x plus 2 together are a systems of equation. You can estimate the solution of a system of equations by graphing the equations on the same coordinate plane. The ordered pair for the point of intersection of the graphs is the solution of the system because the point of intersection simultaneously satisfies both equations. Think back to the last example where you had an intersection at the last hour there. That's what we're going to be looking for, but on our graphs. Now, as we look to solve the system by graphing, we're given two equations, y equals x minus 1 and y equals 2x minus 2. Let's first look at our y equals x minus 1. Here we have a slope of 1, as this is in y-intercept form, and we have a y-intercept of negative 1. So we can start by plotting our point with our y-intercept at negative 1. Now our slope is rise over run. So this is actually 1 over 1. So we can go then from our y-intercept up 1 over 1. And from that new point, up 1 over 1. Now up 1 over 1, as you can tell, if we go backwards, is the same thing as down 1, left 1, down 1, left 1. So continue doing that. Down 1, left 1. And down 1, left 1. And now as neatly as you can, try to sketch in that line. Right around there. And that's our y equals x minus 1. The hint here is we don't have a coefficient with the x, which means we just have a slope of 1. 1x is the same thing as x. Now as we look at our next equation, we have y equals 2x minus 2. Well, our slope here is 2, while our y-intercept is negative 2. So we have a y-intercept at negative 2. And our slope, once again, 2 is the same thing as 2 over 1. So we can rise 2 while we run 1. How does that look? Start at your y-intercept and rise 2 and run to the right a positive 1. Puts us right there. That might be our answer. Let's just graph a couple more points though. Rise 2, run 1. And we can from there rise 2, run 1. And if you notice, if you go backwards from the points we've drawn, you can drop 2 and left 1, down 2, left 1, down 2, left 1. So if we do that to the other side of the graph, we can down 2, left 1. And now we can draw our line in here as neatly as we can. And hey, we have an intersection point. right there. We have a point of intersection. And that point is at 1, 0. So our estimate here, based on the graph, is the point 1, 0, where these two equations intersect. Now we can actually check our work here. If we start with our first equation, y equals x minus 1, if we put in 1 for x and 0 for y, we should get the left side equal the right side. So we should get 0 for y, 1 for x, and 1 minus 1 is 0, so we have a check there. We can do the same thing with our other equation, 2x minus 2. If we put in 0 for y and 1 for x, 2 times 1 is 2, minus 2, well, I get 0 equals 0. So our answer to the systems of equations question is 1, 0. So what did we do here? We looked at the equation, found the slope and the y-intercept and graphed. We did the same thing with the second equation, looking at the slope and y-intercept, and we graphed. And we came up with a point of intersection here at 1, 0. Now before we just assume that that's our answer, we need to check. So we can put the 1, 0 back into both equations and check it. If the left side equals the right side, we know we're right, and we are. So our answer here on this question is 1, 0. As we look at our second example of this type, we can do the same thing. We need to graph both equations, y equals 4x and y equals x plus 3. So if we start with our y equals 4x, we have a slope of 4, which is 4 over 1. So we're going to rise 4 and run 1 from our starting point, which is our y-intercept. Well, y equals 4x. 4x plus what? Well, 0. So our y-intercept is actually 0. So we can graph our point at 0, 0 for our y-intercept on this equation. And our slope is 4, so we're going to rise 4 and run 1. So from our starting point, which is our y-intercept, we will rise 1, 2, 3, 4, and run 1. Now we can't go any further up here on this graph. And again, notice we went up 4 and over 1, and that's the same thing if we go backwards as going down 4 and over 1. So we can do that same thing, go down 4 and over 1. And as neatly as you can, it might not be easy, but sketch this graph in here as linear as you possibly can. And I know mine's a little squiggly, but try to draw it as straight as you can. Now our other equation is y equals x plus 3. And so we once again, like the other example, our slope is 1. This is just 1x. So that's 1 over 1, so it's a rise 1, run 1 situation again. And our y-intercept this time, our b here is plus 3, so it's just 3. So we can start here at 3 with our y-intercept. And our slope is 1, so we can start at our y-intercept and go rise 1 over 1 and rise 1 over 1. And again, backwards is down 1, left 1, down 1, left 1. So we might as well go that way too. Down 1, left 1. And we have our intersection, so we have enough points to graph here. Draw your line in as neatly as you can. And look for the intersection. It's right there. Where's there? Well, here. And that's at our point 1, 4. Now again, before we can assume that that's our answer, we need to check. and we're saying our answer is going to be 1, 4, hopefully. So with our equation, y equals 4x, substitute in the 4 for y, and the 1 for x, and 4 times 1 is 4, so the red equation works, y equals 4x, so that's checked out. And in our blue line, y equals x plus 3, substitute in the 4 for y, and the 1 for x, and hey, 4 equals 4 again. So our answer is where the two lines intersect, which is at 1, 4. So again, what did we do here? We graphed two lines, y equals 4x and y equals x plus 3. We found the point where they intersected, which here was 1, 4. We did a check step though. We rewrote both equations. We substituted in our x, y, got the left side to equal the right side for both, so we know that 1, 4 is our answer. Now we can also do this in word problems. Creative Crafts gives scrapbooking lessons for $15 per hour plus a $10 supplies charge. Scrapbooks Incorporated gives lessons for $20 per hour with no additional charges. Write and solve a systems of equations that represents the situation and then interpret the solution. Well, let's do Creative Crafts in red here. I'm going to underline the Creative Crafts information gives scrapbooking lessons for $15 per hour plus a $10 supply charge. So Creative Crafts is where we'll start. Well, if we just use words first, our total cost here is going to equal 15 per hour plus that $10 charge. So we can almost say it's going to be 15 per hour, so 15 times our number of hours, plus that $10 supply charge. So if I interpret this into an equation, this would kind of be y equals 15x, so x is per hour, plus 10. And that's the equation for Creative Crafts. We have a slope of 15, which is 15 over 1, and we have a y-intercept of 10. So we can draw our first point here for Creative Crafts at 10, since that's our y-intercept. And now we're going up 15 and over 1. Well, notice our graph here is counting up by tens. Our hours are by ones. So when we go up 15, we're not counting up 15. We're wanting to make sure we go up 15. So 10 plus 15 is 25, which is right around here, over 1. And then from there, we'll go up 15 from that 25, which gets us to 40, and over to 2 hours. Up 15 from there is to 55 and 3. Up 15 is 70 and 4. Up 15 is 85 and 5. And up 15 from there is 106. And I can draw my line in as neatly again as I can. Since we're looking for intersection points here, it's really important to draw our lines as neatly as we can. So that's our Creative Crafts line. What about Scrapbooks Incorporated? Well, let's do that one here in blue. And they're just $20 per hour with no additional charges. So if I look at Scrapbooks Inc., their cost is simply $20 per hour, and they don't have any charges. So y equals 20x. So I can interpret this then as my slope being 20, or 20 over 1. And my y-intercept, well, it's not that I don't have one with no additional charge, it's just my y-intercept is 0. So my y-intercept here is 0. And now I'm going to be going up 20 and over 1. So up $20 over 1 puts me right here. And then from that mark, I'm going up 20 to 40 and over 1 to 2. Up 20 to 60 over to 3. Up 20 to 80 over to 4. And up 20 to 100 and over to 5. And I have my line now. And hey, I have an intersection point. And that intersection point is right where I'm shading in now at 240. Now it still is good, even though it's a word problem, to check these. And I'll do that down here. If I look at my first equation, I have y equals 15x plus 10. And we have the point 240. So I can substitute in 40 for y equals 15 times 2 plus 10. And 40 is going to equal, 15 times 2 is 30 plus 10. And so 40, I can squeeze it in down there, equals 40. So that side's good. And if I do the other equation, y equals 20x, our y is 40, our x is 2, so 40 equals 40 again, so we are good to go there. Our left side equals our right side. So we are checked out, and our answer here is 240. Now again, we need to know what this means. Now our ordered pairs here are x or our hours, whereas our y's were our total cost. And so that's helpful to know as we try to write a statement here. So if we look here, we can say, if you take lessons for 2 hours, the costs at both stores is equal, which is at $40. So it takes it 2 hours to get to the equal point. And that's it. So in this question, we looked and we said, okay, $15 per hour plus $10, and we wrote an equation for that, found the slope and y-intercept and graphed. We did the same thing for the second company, wrote an equation and used the slope and y-intercept to graph. We found the point where they intersected, which is at 240. We still want to make sure we check our work. And then as we interpret, we go, okay, 2 hours, total cost was $40. That's where they met. That's the answer to our system of equations. So if you take lessons for 2 hours, they're both equal to $40. Now sometimes you're going to have just one solution in a system of equations problem, and so far our first 3 examples have just one solution each. However, that's not always the case. So the first ones, they intersected in the lines, so there was one solution. However, sometimes we have different situations. If the lines are parallel, there's no solution, because there's not going to be an intersection point if the lines are parallel. However, if the lines are the same, there's an infinite number of solutions. Basically, the lines would be overlapping. So as we look at our equations here, y equals 2/3 x plus 3, we can go ahead and attempt to graph that now. And if we look at our equation, y equals 2/3 x plus 3, we have a slope of 2/3. So we're going to rise 2 and run to the right 3. And our y-intercept is going to be a positive 3. So our y-intercept, we're counting by 2's on this graph, so it's going to be between our 2 and our 4. And as we go up 2 and run 3, be careful because we're going up to 5, which is right here. So it's not like we're going 1, 2, although you could. You just have to be really careful if you're going to do that. But as we rise 2, we're going from 3 to 5, and our run of 3 is 1, 2, 3 out kind of here in the middle. We'll rise 2 and run. Oops. Actually, we'll rise 2 up to 7 and run to 6. And we'll stay there and draw our line in as neatly as we can. Let's look at our next equation. 3y equals 2x plus 15. Now, so far we've only graphed using slope-intercept form. You can also use the intercepts, meaning if I want to look at my x-intercept, that is where y equals 0. So I could solve this equation and say, okay, 3 times 0 equals 2x plus 15. And go, all right, 0 equals 2x plus 15. Subtract 15 from both sides. Negative 15 equals 2x. Then I could divide by 2 and divide by 2. And negative 7.5 is going to be my x-intercept. So my x-intercept is negative 7.5, which is somewhere right around here. And then I could also try to solve for my y-intercept, and that's where x equals 0. So I can look at my equation and go, okay, 3y equals 2 times 0 plus 15. Of course, 2 times 0 is 0, so I'm left with 3y equals 15. Divide by 3, and y equals 5. So my y-intercept is 5. And I can try to draw as straight of a line as I can here. As I go out here. And now I have these two lines. But these look parallel. These look like they're never going to intersect, and in fact they're not. And these lines are parallel. Never going to intersect. So for this question, we can actually write that there is no solution, as they are parallel and will never intersect. So as we solve this equation, the first equation we solved using the slope and y-intercept. The second one you could get this into y-intercept form, and actually you could do that by dividing by 3 here. And if you divide everything by 3, and I'll show that just on the side here, just to give you another option to solve this if you don't want to use the intercepts, you would get y equals 2/3 x plus 5, where you'd have the y-intercept of 5 that we found and the slope being the same. Well, hey, our slope's the same. We have different y-intercepts, so again, that kind of shows they're going to be parallel. Or you could solve using the x and y-intercepts, is what we did the first time. You could solve that equation and graph it either way. But no matter what, no matter how you choose to graph it, you have two parallel lines here. They're never going to intersect, so there is no solution. Now as we look at a second example of this, we're given the equations y minus x equals 1 and y equals x minus 2 plus 3. And we want to solve this system of equations by graphing as well. So we have in our first one, y minus x equals 1. Let's get this into slope-intercept form into our y equals mx plus b, and we can do that by adding x to both sides. That's going to cancel, and we're left with y equals x plus 1. Well, that tells us that our slope is, well, it's 1x, so it's just 1, or 1 over 1. And our y-intercept is also 1. So we can draw a point at 1, where y equals 1, and we're going to once again go up 1 over 1, up 1 over 1, And again, remember, that's the same thing if we're going up 1 over 1, up 1 over 1 is down 1, left 1, down 1, left 1. So do that again, down 1, left 1, down 1, left 1 to get 2 more points. And then we can draw on our line as neatly as we can. We're going to be looking for those intersection points. So this is the line y minus x equals 1. Now, let's look at our next equation. Y equals x minus 2 plus 3. Let's simplify this. Negative 2 plus 3, you get, let's see, negative 2 plus 3 is a positive 1. Wait a minute. We just graphed that. We have a slope of 1. We have a y-intercept of 1. It's the same equation. It's y equals x plus 1 all over again. So actually, they're right on top of each other. I once again have, even though it says y equals x minus 2 plus 3, the graphs are on top of each other. It's the same line. And as we're reading this third bullet point, if the lines are the same, there are an infinite number of solutions. Well, they're overlapping lines. They're exactly the same. So our answer here is infinite number of solutions. Both these equations, we had the same slope and the same y-intercept, compared to the other one where we had the same slope but different y-intercepts where they were just parallel. Here we have the same slope and the same y-intercept, and they're just on top of each other. It's an infinite number of solutions. And here we have our summary. When a linear system of equations has different slopes and y-intercepts, there is one and only one solution. Those were our first few examples where we had different slopes and different y-intercepts. However, when we have the same slope and different y-intercepts, there's no solution. Those were our parallel lines. We had the same slope, but different y-intercepts, so there was no solution. And then the last example we just did, we had the same slope and the same y-intercept. So there was an infinite number of solutions. So now without graphing, we're asked, a system of equations consists of two lines. One line passes through 0, 2, and 1, 4. The other line passes through 0, negative 1, and 1, 1. Determine if there's no solution, one solution, or an infinite number of solutions. And again, we're going to do this by comparing the slopes and y-intercepts. We're not going to actually do this with graphing this time. So to compare the two lines, we're going to write an equation of each line in slope-intercept form. And that means we need the slope and the y-intercepts. So let's find the slope of each line. If we start with our 0, 2, and our 1, 4, and we do our classic x1, y1, and x2, y2, our slope is equal to the change in y's, y2 minus y1, over our change in x's, x2 minus x1. So our slope is going to equal y2, which is 4, minus our y1 of 2, over 1 minus 0, which simplifies into 2 over 1, or just 2. Now let's focus on this line first, and then we'll move on to the next one. We want to find the y-intercept of each line, then write the equation. So we can start with y equals mx plus b. We know here our slope is 2. Now we can use the point 0, 2, and wait a minute, our y-intercept by definition is when x is 0. Well, we already have that. X is 0. So our y-intercept b is going to be 2 because it crosses the y-axis at 0, 2. And so we can write this equation as y equals 2x plus our b of 2. Again, because we're given the y-intercept there at 0, 2. Now if we look at our last point, we're given 0, negative 1, and 1, 1. And again, we can write our x1, y1, and our x2, y2. Our slope of our line is our change in y's, y2 minus y1, over our change in x's, x2 minus x1. And y2 is 1 minus a negative 1 over x2 is 1 minus 0 again. 1 minus negative 1 is 1 plus 1, so 2 over 1. So once again, we have a slope of 2. So as we look at this equation, we're given a slope of 2. And if we look at our 0, negative 1, that tells us that our b is negative 1. Our y-intercept is negative 1. Again, because our y-intercept is where x is 0, and it gives us that point in this question. So if we look at y equals mx plus b in slope-intercept form, our y is going to equal our slope of 2x. Our y-intercept is a minus 1. Now we get to compare. We need to compare the slopes and the y-intercepts. Well, as we compare the slope, our slopes, we have 2 and we have 2. So our slopes are the same. But as we compare our y-intercepts, we have, in our red equation, we have 2. And in our blue equation, we have negative 1. So let's recall what that means. If we have the same slope, which is what we have, and different y-intercepts, which is what we have, there is no solution. All that work just to get an answer of no solution. So we have different slopes and we have different y-intercepts. So our answer here is no solution. Systems of equations can be a lot of fun. I hope you enjoyed this as much as I did. Good luck.